Hey everybody, welcome to the first video in video module 6 in the simulation-based planning and scheduling course. In this video module, we will focus on an implementation plan, or an implementation example actually, for case study 03, which is ABI electronics. Note that this is a two-part lecture video module sequence, so you should definitely watch the lecture from this week before you look at, or before you watch this video module. In the lecture, we define the problem, talk about the conceptual modeling and implementation plan and so on. And here what I'm going to do is just give a very brief overview of the problem and then really jump into the implementation example. And so the ABI electronics, or what we're interested in modeling here, is a flexible flow line. You can see that we have 4 stages: kit, assemble, finish, and package, and that 2 of those stages, assemble and finish, have multiple parallel stations in this example, which are identical. And that we are processing orders, where an order consists of a particular module that is a particular color. So we have 3 different module types, and we have 4 different colors, and then we have a order arrival date and an order due date. We have the additional details here that, again, we went over in the lecture. We're going to use all of this data. And so at each stage, kit, assemble, finish, and package, you can see that we have 3 different processes. We have setup process, a process, and then a finish process, and that all of those times are different or can be potentially different by module, by station, and so on. We also have the bill of materials. So, for example, module A requires component A, 2 of component B, and 4 of component C at the kitting operation, requires the paint at the finish station, and a particular type of packaging, in this case, box A. Also note that the finish depends on the color of the order. So when we say paint here, it could be one of 4 colors as specified right here. Also note that the finish station has sequence-dependent setups, and so when you switch from one color to another at a particular station, you incur this sequence-dependent setup. And so during the conceptual modeling phase in the lecture, we went over this notion of several different, that there are several different aspects of this problem which we haven't seen before, and so we elaborated on those and talked about design alternatives. In particular, with this notion of workstations and centers. So we said, if you look at the assemble and finish here, we're going to define a workstation is being comprised, or I'm sorry, work center is being comprised of 3 different stations. And so from an implementation standpoint, in our implementation plan, we're going to use a server type object here, which will probably be will definitely be a custom object of class server, and that we'll then use transfer nodes to select from among the stations in a particular work center. And so when an order entity comes to the transfer node that is part of the work center, it'll then select the appropriate station based on the overload function. And also within the stations, we'll use task sequences to implement the 3-phase process, where we have setup, process, and finish, and that there's consumption of raw material within the setup. So in the kitting operation, we consume the components. In the kitting operation, we consume the paint, and in the package operation, we consume the packaging. And the last thing we did on Monday, or in the lecture class, was to lay out the table structure, kind of like an ER diagram, not exactly, that we will implement in the model to drive our data-generated, data-driven model. So again, I'm not going to go through this in detail. I strongly recommend that if you haven't done so, go back and watch the corresponding lecture here before you watch the rest of this module where we do the implementation. The implementation is split into 2 different videos, so we're implementing the same model. I just split it into 2 different videos.